We are still in Chapter 4, still in Section 1. I'm on page 199, and this is the brief version of our textbook. I'm starting here at the middle of the page where it says probability rules. You might note that I have green, underlined, pencil, a little asterisk with a circle, got lines over here, information, highlighter. You might want to do the same. You might want to pull out an index card or your glossary list. Whatever you're doing, but highlighter, sticky notes, pen, pencil, whatever would be really good for this on our probability rules. It says on number 1, the probability of any event is a number. And remember how we've had fractions or decimals. But here's the big thing. That's going to be between and including 0 and 1. And they note it here. The probability of an event occurring is less than or equal to 1, and then when we read backwards, the probability of the event occurring is greater than or equal to 0. In other words, 0% chance to 100% chance, and we can think of rain. The sum of the probabilities of all of the outcomes is going to always, in a sample space, be 1. In an event E, if an event E cannot occur, in other words, it contains no members in the sample space, then its probability is 0. And if an event E is definitely certain, then it's at 1. In other words, 0% or 100%. When the probability of an event is close to 0, its occurrence is highly unlikely. When the probability of an event is near 0.5, there's about a 50% chance that the event will occur. And when the probability of the event is close to 1, it is highly likely. And they give us a nice little chart. On the next page, we have 2 examples. We have example 4.8 and 4.9. And I have smiley faces and LOLs and more LOLs going on these. Earlier we talked about how to write our probabilities, so I'm going to start right here. When a single die is rolled, find the probability of getting a 9. When a single die is rolled, find the probability of getting a 9. So the probability of getting a 9 when I roll a die. The probability is, okay, I got to put in the numerator how many sides have a 9 on them. How many sides have a 9? Well, none. Out of how many sides? Still 6. And so it's a 0. It's not going to happen because there ain't no 9 on this die. I know there are different dice out there, but this one, basic, it's not happening. And then on 4.9, if a single die is rolled, what's the probability of getting a number less than 7? So what's the probability of getting a number? And we can use it in words. I'll just do this. A number less than 7. That means we can get a 6, we can get a 5, a 4, a 3, a 2, or a 1. So there are 6 sides that have a 5, a 6, a 6, a 5, a 4, a 3, a 2, or a 1 out of the 6. And so that is going to be a 1, hence more LOL. So the second one is certain, and it didn't mention up on the other one. It just is not going to occur. It just is impossible, not going to happen. We then go down to this next part talking about complementary. I haven't mentioned your formula card, but I do want to pull up the formula card and notice that we're in Chapter 4. And in Chapter 4, I'd like you to see it is on your formula card. It says it's got a P and it's got an E with a bar on top of it, and then it says 1. Remember certainty? Minus P, the E without the bar on top of it. So note that, and it happens to say here, another important concept in probability of theory is that of the complementary event. And the complement is, it's the set of outcomes in the sample space that are not included in the outcomes, and it's noted by, remember how I had a bar over it? It's noted as E bar. And so we're going to play around with a few of these, starting with select a day of the month, selecting a month that has 30 days. Select a month that has 30 days. And so I would always question, what are they saying? What are they not saying? But for a month that has 30 days, is that exactly 30 days, at least 30 days, not less than 30 days? I'll go ahead and see what they said. Select a month that has 28 or 31 days. So they want exact. And so which months have that? Well, I have to show you something from my youth here. You get your knuckles and start at the left. January, February, March, April, May, June, July, August, September, October, November, December, and all of your knuckles are 31 days. Well, we don't want the knuckles. We don't want February because it's going to be 28 or 29, so that would not be January, February, March. It'll be April, June, August, no, September, November. So how many ever I just counted? I lost count. So it says select a month that has 30 days. That is, it's the complement. I am so sorry, y'all. I'm just over here. I didn't even read the directions. So let me go back and read the directions. Find the complement of each event. Well, I'm going to go ahead and keep going in the vein that I am going in. I'm going to go ahead and find the probability that a month has 30 days. So it's not January, February, March, but it is April, June. So April, May, June. Oh gosh, January, February, March, April, May, June, July, August, September, October, November, and then December's got 31. So we got 4 out of the 12 that do have 30 days. The complement wants to know the not of that. So I want to find the probability that a month does not have 30 days. So I'm going to do 1 minus my 4/12, and 1 minus my 4/12 will be 1 minus 1/3, which that will be 2/3 of the months. I have no idea where they are or what they're doing. Oh my gosh. They're not even doing what I'm doing. I'm sorry, y'all. They are just looking for the not. And so the not would be, I mentioned April, June, September, November. So they did January, February, March, April, May, June, July, August, September, October, November. Anyway, these are they. I need to read the directions before I even start talking to you guys. So the next one says, select a day of the week that begins with the letter S. So we're going to pick the not of that. And the not would be everything except Sunday and Saturday. So it would say Monday, Tuesday, Wednesday, Thursday, Friday. I did one right. Yay. And then the next one, rolling 2 dice and getting a number whose sum is 7. And we want to roll 2 dice and get a sum that is not 7. A sum that is not 7. So looking at our die, we have 4 and 3. Those would be 2. That would be the 7. And this would be a 7. But it doesn't want to know the dice. It wants to be, if it was 7, that's what we want. Then what is not 7? Well, let's start with the lowest. And the lowest would be, we could get 2. So that's where they have listed. We could get a 2. We could get a 3, a 4, a 5, a 6. Oops, we don't want to include 7. 8, 9, 10. How far do we go? Well, the biggest sum we can get is 12. So we'll keep going on up to 12. And then, oh my gosh, we can all argue about this one. Select a number or a letter of the alphabet that is a consonant. And there aren't even any answers around on this one. Oh my gosh, I got to read the directions. I am rushing and I am so sorry. The question is, select a letter of the alphabet, excluding Y, that is a vowel. And we're going to select all of the ones that are not vowels, but we can include Y. And that will be all of the consonants, so everything except A, E, I, O, and U. Oh my goodness, let's get off of that page and let's go up here to page 201. So on 201, we have that the outcomes of an event and a complement make up the entire space. And so what that's saying is, what is in our event and what is not in our event, together, we got it all. It's everything. Since the event and its complement make up the entire sample space, it follows that you could play around with this a bit. And so on our card, it just lists the probability of E bar, the complement, is 1 minus P of the event, the probability of the event. Then here on this page, it plays around a little bit more. It says, you know, you can also say that the two of them added up is that one whole. And I put in here that it's wrong in the ebook. So when you're looking at the ebook, make sure that you match what I have here, that the probability of the E-bar is 1 minus the probability of the event, or the probability of the event is 1 minus P probability of E-bar, and then the sum of them would be 1. Stated in words, if the probability of an event or the probability of its complement is known, then the other can be found by just subtracting it from 1. Probabilities can be represented pictorially with Venn diagrams. I like this one. That's got the probability of the event and the probability of the complement, and together they make up the whole. So I'm going to hope that I do better on this piece of the homework. And on this piece of the homework, I'm at the bottom of 201. At the bottom of 201, it says, in a study, it found that 24% of people who were victims of a violent crime were ages 20 to 24. If a person is selected at random, find the probability that the person is either younger than 20, in other words, the number we just got from 20 to 24. So who's not this? Younger than 20 and older than 24. So it's the nots. So to find the probability of our E-bar, the ones who are not 20 to 24, and if you want to say that, they're not 20 to 24, it's going to be 1 minus what we were given for the 20 to 24. I must do it as a decimal. And when I subtract these two, I believe I'll get, but the way things are going, I'm not real sure, I'll get 0.76. So looking at their work, they did not, they did the subtract. Here's the 7600ths. It could also be represented back as a percent since we were given a percent. And we are done with classical probability.